Okay, let's revisit the arc length of a circle and talk about area of a sector. Okay, so you may recall that radians are defined in terms of arc length in context of this formula, S equals R theta, if we're measured in radians. So if somebody asks me for an arc length, the length of this little red area or red distance here, and they give me a central angle in radians and some radius, then finding the arc length is easy, S equals R theta. But I have to be in radians. If they give it to me in degrees, I either have to go back and use that old method that we learned in a previous video, or I have to convert that angle to radians first. So let's look at an example. Oh, here's a good example here. So they give us this central angle of 215 degrees. So that's more than 180 degrees. And we're told our radius is 10. I want the length of this arc over here, S. So a couple of different ways I can do this. I could, method number 1, do this in degrees, because they gave me degrees. And I could say the angle in degrees out of 360 is the arc length I'm looking for, S, out of all the way around the circumference, which we know is 2 pi r. So that would be 215 degrees out of 360 degrees will be S over 2 times pi times 10. So 2 times 10 would be 20 pi. And I could just multiply over and throw everything in my calculator. In fact, let's just do that. So this 20 pi is going to be multiplied up here. 20 times pi times 215. The degrees just cancel. So I don't need degrees anymore. There's nothing there. Over 360. And I got my fancy calculator here. I can just type that in. 20 times pi. There's my pi button. I have to hit second to get to it. Times 215 divided by 360. And I get about 37.52. And I need units here. Arc length always has units of length. Whatever the units of my radius are, if they're in feet, arc length will be in feet. Well, here we're just told units. So my units are units. Same units as the radius. Or I could do this in radians. I know S equals R theta. But that angle there must be in radians. If I want to use this simple formula, I have to go through all the work of converting that angle first. So let's do that. 215 out of 360 will be the angle I'm looking for in radians out of 2 pi. And I'm going to go ahead and simplify this. The degrees cancel. Let's see. I know 5 goes into top and bottom. So let's say 215 divided by 5 and 360 divided by 5. I have 43 over 72 equals my angle in radians out of 2 pi. Multiply the 2 pi up, and I'll have 2 pi times 43 over 72 equals my angle. And then I could do a little canceling here. 2 goes into 72 36 times. So my angle would be 43 pi out of 36, and then I just do S equals R theta. Now that I'm in radians, I can just use this angle and multiply by the radius, and I'm done. And my radius, I believe, was 10. Yes, it was. So S will just be 10 times that fraction. And I could make that 10 over 1 and just multiply across the top and across the bottom. So 10 times 43. And of course, I could have done some of this in my head. Pi divided by 36. And look at that, we get the same answer. 37.52 if we round to two places. And I have to put units here. If they told me feet, I would have to write feet. Arc length and radius always have the same units. It's just units of length. So my recommendation to you is, if they give you the angle in radians, S equals R theta. Just use this formula. If they give it to you in degrees and you can easily convert it, like we know 30 degrees is pi over 6 radians, just convert it. S equals R theta, you're done. If it's a nasty angle like 215, I would go through this process. I mean, technically, we're kind of doing the same math. If you look here, all we're doing is waiting till the end to multiply by R here. We're kind of doing the same math. But this just kind of does everything at once. Easy angles, use S equals R theta, but convert first. Hard angles, set up your proportion. Okay, what about area of a sector? So it's just like arc length, only now we're looking for this blue shaded area here if we have some radius and some central angle theta. So there are two ways we could do this. If we're in degrees, it's just like we did with arc length. The angle out of all the way around will be the same as the area we're looking for out of all the way around. What's all the way around? What's the area of a circle? Pi r squared. So we can set up this proportion and solve. Or if we happen to know our angle in radians, there's our formula there. I prefer to think of it like this. I'm going to write it slightly differently than they wrote it. 1/2 r squared theta. Don't worry about where this formula comes from. I'm not going to prove it here in this class. You just believe it. If your angle's in radians, area of a sector is 1/2 r squared theta. Okay, and we have this angle, or this example here. Let's do it both ways. So we'll do it in degrees, and then we'll do it in radians. So in degrees, 30 degrees out of all the way around is the area I'm looking for, A, over pi r squared. R here is 20. 20 squared is 400. So I'm just going to write this bottom as 400 pi. Now, personally, I think it's better if we just go ahead and reduce this fraction first. Like, I can cancel the degrees. I can cancel a 0. 3 goes into 36 12 times. Multiply the 400 pi up, and my area will be 400 pi over 12. It's an ugly 12. Let's write that a little prettier. And then we can get our fancy calculator out. 400 times, there's our pi button. I have to get second to get to it. Divided by 12. 104.72 if we round to two places. Now I need units here. Area has square units, square feet, square meters, square inches. In this case, our radius was in feet, so this will be square feet. or feet squared. Or, now, what I did there was perfectly fine. Nothing wrong with it. I can do the same problem in radians, but I have to convert to radians first. I know A is 1/2 r squared theta, but I must convert to radians before I can use this formula. Very common mistake here. People want to use this formula because it's simpler, but then they just want to use the 30. Look, let's take a look and see what happens. If I did 1/2 times r squared, like I'll even write it, 20 squared times 30, that's the wrong answer. It's not 6,000. The answer is 104. If we're going to use this formula, we have to convert to radians first. Well, it's a good thing we know 30 degrees is pi over 6 radians. So now I can just use the formula. A will be 1/2. R squared, 20 squared, we know is 400 times pi over 6. Just make all of these a fraction. Multiply across the top and across the bottom. A will be 400 pi over 12. That's the same answer we got here. I don't have to type that in a calculator again. It's the same answer. So this way is easier if you can easily convert the angle into radians. If you can't, if it's some nasty angle, set up this proportion. And that's a good place to stop.